So on the previous video, we did questions 1, 2, and 3. Right now we're going to jump to question 4. And we're going to follow the shortcut steps to factoring this quadratic trinomial that has an a value of 8. So step 1 is to multiply a times c. And what is 8 times negative 10?
Negative 80.
Negative 80. Okay, so now we need to think of the multiples. Step 2, think of the multiples of negative 80. I always start with 1 or negative 1. Negative 1 times 80, negative 2 times 40, negative 3 times nothing, negative 4 times 20, negative 5 times 16. And by the way, if you're not good at these multiplication tables, all you have to do on a calculator, say 80 divided by 5, and you'll get your answer 16. That way you know that 5 times 16 is 80. How about negative 6? Does that work? No. Negative 6 times... It does not work?
No.
How about 7? 7 doesn't work either. Negative 8 times 10, that'll give you negative 80. So those are all the possible combos that multiply together to give you that number, negative 80. Now, which of those pairs of numbers combines together to give you the b value, which happens to be negative 5, sorry. So it's none of those, right? I mean, if you start adding them up, negative 1 plus 80 is 79. This is 38. This is 16. This is 11. This is 2. So none of them give you negative 5. So at that point, it doesn't matter which method you're doing. At this point, you say that you can't do it. You write prime. Or you could say not factorable. I think the worksheet says prime. Let's move on to number 5. Step 1, multiply a times c. A times c is what?
Negative 18.
Negative 18. Step 2, think of the multiples of negative 18. Negative 1 times 18. Negative 2 times 9. Negative 3 times 6. And that's about it. That combine together to give you the middle value, which happens to be 7. Right? So which pair of numbers combines together to give you the middle value, 7?
Negative 2 and 9.
Negative 2 and 9. Okay, so using the not factoring by grouping, I'm not going to turn this into a polynomial. I want to just jump to that shorter, most recent version of factoring. I want to plug it into my answer format. Now, remember, it's going to be that a value, 6, in both spots with an m. Now, that does look weird because 6m times 6m is 36m squared, not 6m squared. But remember, the last step is to reduce it. We're going to get rid of one of these 6's in some sort of way or other. Anyway, step 3 is to plug it into your answer format. Plug what into your answer format? The pair of numbers from step 2, which we said this is the pair of numbers. So I'm going to plug in that minus 2 right there and that plus 9 right there. This was step 3, to plug in those two numbers into your answer format. Now, step 4 is to reduce each of the binomials by a GCF, by each of their GCFs. Now, I say reduce, it's kind of like dividing by the GCF. So on the first binomial, the 6 and the negative 2, what's in common? What's the GCF right there? You could reduce by 2. So 6 divided by 2 is what? 3m. And 2 divided by 2 is 1. So you really have 3m minus 1 as part of the first binomial of your answer. And in the second group, what could I reduce by? What's the GCF in the second group?
3.
It's 3. So if you divide by 3, you end up with your second binomial, which is 2m plus 3. Ladies and gentlemen, it can't get any easier than that. Now let's say you're not too sure about it. You could distribute combine like terms and see if it really does give you the original quadratic trinomial. But this is way easier, way faster than the previous method of factoring by grouping. Okay? Bless you. Number 6. Always try to pull out a GCF. So number 6, step 1, multiply a times c. And what is a and what is c? It's 10 times negative 20. 10 times negative 20 is negative 200. Okay, that's huge. But that's okay, you guys could use calculators. Step 2, think of the multiples of negative 200. So I'm going to start with negative 1 times 200. Negative 2 times 100. Negative 3 times, it doesn't work. Negative 4 times 50. By the way, if you don't know these off the top of your head, get a calculator and take the 200 and divide it by 4. And you'll see that the answer is 50. That way you know that 4 times 50 is 200. Now if we try negative 5 times, what is that, 40? Negative 6, does negative 6 work? With the calculator, do 200 divided by 6. I just did it with the calculator. I got 33.3, so I know that 6 does not work. If I go for 7, it's not going to work either. 200 divided by 7, 28.57, so I know 7 doesn't work either. But when I go to 8, 200 divided by 8 on a calculator is 25, so negative 8 times 25 does really give me negative 200. Now, let's stop right there, because the whole purpose of doing this is to check which pair of numbers combines together to give you the middle value, which is positive 17. And I already see that this is the correct pair of numbers that I want right here. 25 take away 8 is 17. Now, the old method was to rewrite your b value as these new two terms. That way you could get a polynomial. That way you could factor by grouping. But right here, with this new awesome method, we simply jump to our answer format. Okay? And our answer format is to plug in your ax value in each one of those. In other words, instead of 10d squared, what am I plugging in here and here? 10d. Just 10d without the square. 10d, 10d. Okay, now that's weird because it doesn't make sense, right? 10d times 10d is 100d squared, not 10d squared. But we're doing this, and later on when we reduce, we're going to eliminate one of those 10s. Anyhow, what do we do with the pair of numbers from step 2? We plug them in. So it's really 10d minus 8 and 10d plus 25. That was step 3, guys, plugging it into your answer format. Step 4 is to reduce each binomial. That's what it says here. Reduce each binomial by dividing it by its GCF. If possible, you might not have a GCF. So the 10 and the 8, what's the greatest? 2, right? You could divide by 2. So that's what I want to do. I want to divide this by 2 and that by 2. And my new binomial, which is going to be part of my answer, what's it going to be? 5d minus 4. How about the other binomial? Could I divide the other binomial by 2? No, by 5. So divide by 5, divide by 5. And guys, we're done. The answer is 2d plus 5. There's your answer. 5d minus 4, 2d plus 5. Number 7. What's step 1? By the way, always try to pull out the GCF first. If you have a GCF you could pull out, it could probably be done even quicker, right? But there is no GCF here, but always try, at least look for it. So step 1, a times c. What is a times c? 72, because 6 times 12 is 72. Then we think of the multiples of 72. 1 times 72, 2 times 36, 3 times, calculator times 72 divided by 3. We get 24, so 3 times 24, 72. 4, let's see, 72 divided by 4 on a calculator is 18. So 4 times 18 is a possibility. 5 doesn't work. 6, 6 times 12 is 72. 7, 8 times 9 is 72. Those are all the possible ways of getting 72. Now, which pair of numbers combines together to give us negative 17? If I combine these guys, no, that's 18. That didn't work. 8 and 9, right? Okay. But 8 and 9 gives you positive 17, and we need it to be a negative 17. So we have the right numbers, just the wrong signs. So change it to a negative 8 times negative 9, not positive 8 and positive 9. So these are the pair of numbers that we're going to plug into our answer format. So our answer format, we plug in right here and here, we plug in the 6a without the square. So we put a 6a right there and a 6a right there. Then we plug in our values of negative 8 and negative 9. And then after that, step 4 says reduce each binomial by dividing it by its GCF if possible. 6 and 8, what's in common?
2.
A 2, bless you. So we're going to divide by 2, divide by 2. Our final binomial, first binomial of our answer is going to be what? 3a minus 4. And on the other one, what could I divide by?
3.
By 3. So we get 2a minus 3 as a second binomial. And that is our answer. If you don't believe me, you could distribute and combine like terms. 3a times 2a, you get the 6a squared. 3a times negative 3, and so on and so on. It will give you the original quadratic trinomial. So this is way faster, way more accurate, way easier than factoring by grouping. Okay, it's the same 2 first steps. It's just step 3 and 4 are way easier. Let's move on to the next one. So on the next one, a times c is also 72, just like on the previous one. So we have the same list. Let me just rewrite it. And when we try to find the pair of numbers that combines together to give us negative 18, we know that 6 and 12 gives us 18. And if we want negatives, it's going to be a negative 6 times a negative 12. So this is the correct pair of numbers that we want, not positive 6 and positive 12, but negative 6 and negative 12. Now the answer format, you put the parentheses. What belongs inside of there? 8w. 8w. Okay, and now we're going to plug in those numbers, the negative 6 and the negative 12 right in there. Right, we got the 2 numbers and plugged it right there and plugged this one right there. And we got the 8w's here from the original. And now we need to reduce each binomial by its GCF if possible. So on the first binomial, we're going to divide by what? 2? 2. The 6 you can't divide by 4, so it has to be 2. So we get what as an answer? And how about the second binomial? What are we going to divide by? 4. Definitely 4 right there. 2 would work, but 4 is the greater common factor, right? So if you divide by 4, our second binomial is 2w minus 3. And that is your answer for number 8. So here are the steps. I'm going to just move them to the side since I already have them memorized. Step 1 is to multiply a times c. Now a is 10, c is 6, b is negative 9. So a times c, what's a times c? 60. 10 times 6 is 60. Step 2 is to think of the multiples of 60. 1 times 60, 2 times 30, 3 times 20, 4 times 15. Now let's say you didn't know 4 times 15 right off the top of your head. Get the number 60 on a calculator, divide it by 4, the answer will be 15, which means that 4 times 15 is 60. You go 5, 12, 6 times 10, 7, 8, 9, that's it. Those are all the possibilities. So we know that step 3 is to go to our answer format. And what belongs right here in the first part of the binomial? This exact value minus a square, like no square. So this is really just 10x right here and 10x right there. Are you guys with me? So let's put a 10x and a 10x. And what about the number here and the number here? That comes from the step 2. Which pair of numbers gave us a negative 9? None. Oh man, really?
Yeah, prime.
That's prime. Okay, so yeah, if we start going through 1 and 60, that's 61, didn't work. 32 doesn't work. 23, 19, 17, 16, none of those. So yeah, this is just prime. I wasted time, sorry. Prime. In other words, not factorable. Let's try number 10. Let's do one that works. Wow. Step 1 is going to be ugly. We need a calculator. Step 1, a times c. Help me out, guys. What's 15 times negative 28? Negative 420. That's very negative. That's a very negative number. Step 2, think of the multiples of negative 420 that combine together to give you a negative 1. Okay, so I'm going to do, we could start out with negative 1 times 420. Negative 2 times, and do it with the calculator. Like, on a calculator, 420 divided by 2, that'd be 210. Negative 3. On a calculator, 420 divided by 3 is 140. So I know that 3 times 140 is 420. Negative 4. Okay, for the sake of time, you could continue going. And once you get to negative 20 times 21, you get the right answer, negative 420. And if you combine those, it really does give you the middle value, the b value of negative 1. Oh, positive 1. I'm sorry. So we need to switch the signs. Thank you very much. So that really becomes a positive 20 and a negative 21. Now, the answer format that we want is this number, 15n squared, but without the square. So it's just 15n in both 15n and 15n. And the numbers, the positive 20 goes right here, and the negative 21 goes right here. That's our answer. All we have to do is reduce the binomials. On the first binomial, we could divide both by what?
5.
By 5. So what do we get as an answer for that first binomial? 3n plus 4. How about the second binomial? What could we reduce by? Not by 5, but by 3. So we end up with what? 5n minus 7. Now, just for the sake of really understanding this stuff, when we first put right here in black, it says 15n times 15n. We know that 15n times 15n is not 15n squared. It's a huge number, n squared. So we need to get rid of one of these 15s, right? Now, when we divide this one by 5 and divide this one by 3, 5 times 3 is 15. That's how we get rid of that extra 15 that was in there originally. Okay, but that's your answer. We're done. Could move on to the next one. Okay, step 1, again, a times c, we get negative 100. It's very important we include that negative sign. A times c is negative 100. Step 2, think of the multiples. Let me just hit pause and make the list for the sake of time. Negative 1 times 100, and let me do the rest. So out of all those possibilities, which one combines together to give you the middle value 21? That would be 25 and negative 4. We don't have to do any sign change either. It's ready to go. So we're going to take that pair of numbers and plug it into our answer format. And inside the binomials, you take the 10x without the square and write it in there. And then you take your values from step 2, the negative 4 and the positive 25, you plug it right in there. And then you try to divide each of the binomials by the GCF. So that first binomial, the 10 and the 4, you could reduce by 2. So you end up with your answer 5x minus 2. The second binomial you could reduce by 5. You end up with your answer 2x plus 5. And that's it.